Hello and welcome back to the lecture of time series econometrics. We have been discussing about the forecasting techniques in time series, and in this lecture we are going to talk about Holt Winter's exponential smoothing method or the triple exponential smoothing method, and we'll actually demonstrate this technique using R. Okay, so let me show you the R panel here. Okay, so first let me actually clean all these diagrams and all other environments here, loaded environments here. So let me just clean all of this. And let me first actually go back and show you the data set that I want to use. So we are already familiar with this data set, this PPI, Purchasing Power Index for the US economy from 1960 to 2002, which is a quarterly data set. So let me load this data set. Why object PPI is not found? So it means that I have to actually, okay, get the data set loaded here. I haven't loaded it yet. So here it is, first, second, I have loaded it. I can plot it also, no problem. So now I can actually go there and I now use a TS function to sort of tell my R that is the time series data. I plot it here. Um, okay, so now now this data looks like it definitely has a trend. I mean, from the window of data that we have, it definitely looks like it has a trend. For seasonality part, it may have seasonality. It looks like there is a variation, and it might have a pattern also. So probably we have a variation here. So we have several ways to actually check it, right? Or to sort of whether it has seasonality or trend or something like that. So for that, first let us install the package forecast. That's a very useful package for any kind of forecasting activity. I don't want to restart R, I guess. So it's installing the package forecast. It will take a little time, and then I have to update this package in my library, which I've just done. Now then there is a command called a GG season plot. Okay, so that basically will sort of divide the data for different years, and if you have say quarterly data or monthly data, it will sort of plot for each data point. So that will kind of show us a repeated pattern across the different years if we can see something, if there is a consistent pattern, right? So let us just do that. So I've just run that. I have defined this data set as a seasonal or the graph as seasonal PPI. Now, if I plot it, so I will get the graph here, and let's see how it looks like. It will take a little time because it's a little computational intensive, because R needs to sort of break down each of this time period and it needs to plot for each of this quarter here. Okay, it's going to take a little time. It's going to take a little bit of time. So it's actually taking a lot of time, unexpectedly lot of time. But yeah, I mean, this one actually takes a little time. Okay, or we could have just skipped that one. I mean, it's not really important. You can do it yourself. Okay, so let's just move ahead. It just shows if the data has seasonality. Like if there's a pattern of seasonality. Okay. Let me just go to the next one. I think it will work. Let's see. Plot X, will it? Ah, it has come actually. The previous one. Great. So you have, okay, yeah, R is this way of working because I already put the command before, right? So how can I skip it? So yeah, so we have this, and you see that for different years, so it has like all these different lines are meant for different years, and this quarter one, quarter two, quarter three, quarter four, these four quarters are there, and you see that there is a pattern in this quarter. Okay, so like in quarter three, probably there is a increase perhaps in most of the data points, but not maybe for all the data sets. So it shows that there might be some seasonality. Okay, so that's basically it. Now we have our good old decomposition method, right? So we can go there. What has happened in the object carbon not found? Oh, I didn't run it yet. And why didn't I run it? Okay, plot X decompose carbon, and then I plot it. Why is it taking time? Oh, yeah. So I think plotting takes a little bit of time here. Oh, actually, I plotted too many things. So yeah, so the thing is, if so, I actually plotted the same thing for CO2, and carbon dioxide emission has a much more clear sort of seasonality than the previous one, because here you see that for every month, so every month there would be a definite pattern. So for example, in summer or in winter, the carbon dioxide emission would be more, particularly for US countries, because or the Western countries or the countries in the northern hemisphere, because or also southern hemisphere. I mean, if in winter you basically need to put a lot of room heater, right? So then you will have carbon dioxide emission, right? Um, so that's the thing, and well, so we plot it and we see that the seasonality is pretty stark. Like in particular August and September, it's pretty low for all the different years. So if that is the case, now we can actually use the next. We now actually can decompose, like use our good old decomposition technique, and we can see, that if there is any trend. So here you can see everything here pretty nicely. Um, all this, we have very nice sort of seasonality. It's a nice trend. So there is yeah, everything we need in this data. We can sort of see the value of y. I mean, if we want to see the trend value, if we can see the seasonality and we can get the value of seasonality here, we can print it. Then we can just plot the seasonality so that we can basically get the seasonal, the pattern here, not all the different patterns we are looking for, but this particular seasonality pattern. And of course, so we can do all this, just experiments to see how the seasonality, how if there is a seasonality or not. Now, why it is important? Well, so you can do that before you run the Holt Winters method just to see if there is a seasonality. There are other tests also, KPSS test. You can just check it to sort of check if there is seasonality. Well, so once we are confirmed that this data might have seasonality, so then when we do the forecasting, we'll be going for Holt Winters forecasting method, which is triple exponential method, because it takes care of level, trend, as well as seasonal component, right? Now, because it has three different components, we have alpha, beta, gamma, three different smoothing coefficients, all right? So now we'll run it. So the moment I write beta equal to false, gamma equal to false, so that means my model will assume that there is no value for beta and gamma, it will only assume alpha. So you can also define alpha, beta, gamma, or you just don't define anything. So in which case the model itself will choose what value to take, okay? So let us just run it. Now we have run it, and if we plot it, okay, great. So what I see, this black line is the original data set, and whereas the red line is my predicted data set, which looks really good here. Or fitted data set basically. I have fitted my model here. Now here, I can, this is another data set I have not loaded here, so it will not run here. But I can actually do this, all right? So I can get the value, fitted values here. I can, if I plot the fitted value, so it will give me the x hat values, okay? X hat values I need, so I'll get the x hat values, predicted values basically. Now I'll also show that I can actually plot basically by defining alpha, beta, and gamma, okay? So let me just do that, and I'll see I will have a slightly different probably the curve, because I have now forced my alpha, beta, gamma on this model. So it will give me some sort of different sort of model. So we can do this experiment. We can change alpha, beta, gamma. We can let the model decide alpha, beta, gamma, and we can check the RMSE value. We can check the AIC value. So all these things you can just simply type like this model name, this name of the this HWPPI basically, that captures the whole to inter process, and you can just get the model, and you can actually see the values of AIC, RMSE, and etc. All right, so if I want to now get the, so here I have fitted the model, right? I have not really forecasted anything. Now if I want to forecast it, I have to use this forecast command. So here I do not use this h equal to something in this command line. I do it separately. And here what I do is I write forecast and forecast dot Holt Winters HWPPI my data set and I predict for 6 periods. Okay, so I take data prediction for 6 quarters. Let me run it, and I get my 6th quarter. You remember that my data actually was till 2002 first quarter, and it has predicted from 2002 quarter 2, quarter 3, quarter 4, and then the next 3 quarters, right? So it has exactly taken 6 quarters as I have wanted. And so you get the data set. So of course it's a prediction, so it will give you the confidence interval because it's a probabilistic. So it will give you a lower bound, it will give you an upper bound. All right. And with this we can actually plot the forecasted value, and we will see that this is how it looks like. You get this blue line, that's the predicted line, and the region around the blue line is basically your confidence interval, right? So that's basically the idea of Holt Winter forecasting technique, and you see that the forecast values are actually sort of it is showing some sort of seasonality as well. It's there is a like a it sort of captures the variance, right? So it's not just like a trend, like a vertical line that we have seen in a Holt method, or just a sort of not vertical, sorry, straight line like we have seen in Holt method, but it has some sort of seasonality captured here. So that's about the hands-on with Holt Winter's method.